All right, these are the answers to page 265. Just a few problems for us to kind of play around with. The first one gives us an equation. It wants to know if we're increasing or decreasing from 2000 to 2003. So from 0 to 3, we want to know, are we going up or down? So if I go zoom 6, we're not going to see much. The window appears to be way up there. But if I hit trace at 0, I see that we're at 2,430. Okay, now that's the question we're asked anyway in B. What is our population? So for 2,000, we're going to say we're 2,430. Now, if I go ahead and hit trace 3, that'll take me to 2003, and we have 2,408.95. Now, if this is population, well, we could round that to 9, but we went from 2430 to 2409. It looks like we're decreasing, right? Decreasing. Now, if we want to see that for sure, we'd have to take our window and move that up. Now, since those are in the 2430s, I'm going to make my maximum 2450, just a little bit above that, and make my minimum, say, 2400. Now, if I hit graph, you'll be able to see that this is indeed decreasing from 0 to 3. All right. Now, the next question, C says, when are we at 2.3 million? All right. All right, so we want to see on this equation, when do we drop all the way down into that 2.4? Now, what's important is to realize that this 2,430, and this is where it gets a little tricky, which I had to look up here. This 2,430, that's 2,430,000. So in other words, this is like 2.43 million people. And so when they want to know 2.3, they really want to know when is this like at 2,300. And that's real sneaky. I don't know why they didn't just keep it at the same rate, but they didn't. It was their prerogative, I suppose. So we're going to go ahead and set a line at 2,300, hit graph. And we don't see it because it's off our window, so we're going to drop that minimum down to, say, 2,200. And now here comes the population graph, and then there's a line. And now we can see that it goes a little bit past 10 years, so we'll go, say, 30 years. Give us enough time. There's the population dwindling for this city. There's the 2.3 million mark. Hit intersect, enter, enter, enter. And it's in 18.9, so about 19 years from t equals 0, which was 2000, so in the year 2019. Okay. And we could get that right off the calculator. We don't have to do any fancy junk. It's fine if you did, but this is a nice way to do it. All right. Now we get to 37, gives us a different equation for some different variables. We have y, we have t, and then we have this mystery k value here that we're asked to find first and then use it to answer a different question. So in the third month, so when t equals 3, they said 10,000 hits, that's our y value. So 10,000 equals 4080 e to the 3k. And we're trying to find out what that k is. So we're going to take 10,000 here. 10,000 divided by 4080. And that gives us 2.451, if you will, equals 3 to the k, e to the 3k. Now, this is an exponential we're not sure about, so we're going to write it as a logarithm. The log base e, so natural log of 2.451 is equal to 3k. And then we're going to divide that by 3. All right, and this will give us our k value. So on the calculator, I want the natural log of this. So I'm just going to go natural log of answer. And then I want to divide that by 3. So we get a k value of 0.2988. All right. And I'm going to keep the real long decimal on here to use it in just a second. So the next question says, well, what would be the hit rate in 24 months? So we're going to use 4080 times e to the 24 times k, with k being this number right there. So on the calculator, what we're going to do is go 4080 times e to the 24 times, and this number right there is the k value. So I hit enter. There's our k value, enter, and we have over we are doing just fine. Over 5 million hits if I round it up. According to this model, we'd be over 5 million hits in the 2-year mark. Then 63 uses something called Newton's law of cooling to try to find out what time did someone pass away. And they took a temperature at 9 a.m. of the body. They took a temperature at 11 a.m. They want to know what's the time of death. So for us, what we're going to do is try the 9 o'clock time, see what time they give us, and see if the 11 kind of confirms it or not. So the way to do this is just to put this temperature in here and see what time you get. So we're going to go -10 times the natural log, and then you have to be real careful here. We have parenthesis 85.7 minus 70, parenthesis, that's the top, divided by parenthesis 98.6 minus 70, parenthesis. Okay, hit enter, and we get 6 for an answer there. So I get t equal 6 for the 9 o'clock one. Now let's try the 11 o'clock one. So if I go -10 times the natural log, and then again parenthesis, this time 82.8 minus 70, divided by parenthesis 98.6 divided by minus 70. I get a syntax error. What did I do? Let's try it one more time, just real quick. -10 times the natural log, parenthesis 82.8 minus 70, parenthesis that closes up the top, divided by parenthesis 98.6 minus 70, parenthesis, enter. There, that's a little bit better. And we get t equal to 8.04. Now, these are in terms of hours. And you can see in 2 hours, it went up 2 hours roughly. So that's a good thing. And that means we can be pretty confident that this person passed away 6 hours before 9 a.m. So we would say at 3 a.m. is when this body moved to a different space.